going to do is, this just came up, and I'm going to do it first using my tools, and then I will show what it is that it is. So basically what I'm going to do is do a squash and stretch rig with a lattice on it. So what I'm going to do first is just throw a joint in here, and one here. And let's name them. So I'm going to use my little tool here. Wrong tool. I'm going to use this tool. Go away, this tool. And we're going to call it ball. I don't know, for lack of, whoops. Ball. There we go. And what I want to do is just split that and then make a joint. This is how I do it. So I'll just show you how I do it. I am set up config. Split joint. Okay. So first I'm going to do is just split that joint. But I don't need that many joints. I really only want 3 because these are going to be my controls. So I'm going to bring this down to 3 or 1. There we go. 1, 2, 3, just like I want. Okay, so now from that, I'm going to make a curve, which is what this tool does. Now I have a curve here. I'm going to hide this temporarily. So that curve is what I'm going to use as a spline joint. Now what I want to do is just make a very simple spline that has squash and stretch to it. So I'm going to use this tool here. You can see that it's all kind of messed up with its up vectors, and that's because I haven't given it any kind of up vectors at all on the spline IK. So if you look at your spline IK solver, or your spline IK handle, and you go to IK solver attributes and advanced twist controls, I do have it turned on by default with the tool, but as you can see, my scene up. So scene up isn't going to do me a whole lot of good because that means it could go any different direction and still be scene up. But instead, what I'm going to do is use the other joints I have here. Let's make them bigger so you can see them. And I'm going to use this one and this one as my start and end. And then I always do this. So I'm going to grab this joint here, go ahead and go back to my, and change this to objects, rotation, start and end. I'll drop that in there, and I'll drop this one in here, and the bottom one is 0, 0. So there we go. And the end one is 01. Yeah, like that. Okay. So by default, it's positive forward axis is positive X, which is fine, and up axis is positive Y. So it's just based on whatever this guy's doing. So let's see how his Y is forward. It's going to do the same thing. So I get out of there. So now if you watch when I rotate this, it rotates it as well. And actually, let's do this. We'll take all 3 of these and unparent them. Let's move this one down here. And let's just try that again. So I should be getting twists, but I'm not. So what have I done here? Auto rotation, start and end. I reverse this, so that should be 0, and this should be 1. So now if I rotate this, there we go, get a nice twist, and I can move it around, and nothing happens because I haven't bound the curve yet. So the next thing I do is take these grids. Actually, let's do this. Let's make this one so it's less confusing. There we go. Take these 3 joints, take this, and do a basic skin bind on there. So now it's going to grab and move that curve around. So our guy is going to follow, right? That's what we want. And now what I want to do is, actually I've got way too many joints. Let's bring this down. There we go. 3 is just fine. But let's do 5. Yeah, so you can see that center there. And I got to redo this. It's just part of the way that my script works. So bing, bing. This is 2. Oh, whoops. 3. And this is 0. That's why I named them, right? Ball 0, 0 joint, ball 0, 3 joint. Ball 2. Yeah, I already fixed that, dude. Okay, good. So you see that the curve is moving that IK around. So what I have a little thing here is called add stretch. So I'll show you what that means in a minute, but now I can actually stretch this around and it'll follow the way I want. And then I'm going to add some boxes here so you can see what it's doing, right? And then I'm also going to do what's called add pow. So what I'm using is a multiply divide set to the operation of power. And then what I can do is actually use that to create squash and stretch on my joints. So what I'm doing is I'm tying that into the scale Y and Z from that pow multiply divide. So that value is what sets how much it's going to affected the power of it, right? So that's, if I go back to that joint, oops, wrong joint, that joint, and I up this, you can see I get much more, and I can reverse it if I wanted to, which is kind of weird, but I'm not going to do that. So grab this one, let's up this one as well. Cool, let's get back to 1. Great. Now let's take this guy, go back to mine pose. Okay, so now I have a very simple squash and stretch sort of rig. I can get rid of those boxes. All right, next what I do is just put a lattice over this entire sphere. So I'm going to do create, deform, create lattice, and what I always do is make my lattices just a little bit bigger. So I'm going to grab the lattice and the lattice base and scale that up. So now I have my basic lattice here, and you'll notice that it almost lines up with those joints exactly how I want it. This is just sort of luck. I knew that by default it's 252, and I have 5 joints. So what I'm going to do now is select my joints and select that lattice and do a skin by skin. And what I want to do is actually do a 1-to-1. So hopefully that'll work. I might have to check that. So now what happens is it's going to go there and squash and stretch that lattice. So this joint is driving the skinning on the lattice, right? Cool. So to make that a little bit softer, as I pull that out, you see it's kind of, it's not great. So, but if you notice, if in your outputs of your FFD, you have your influences. So I'm going to crank that to 10. You see I get something much softer. It's sort of a, I'm just sort of just doing a quick hack cheat to it. You see I can get kind of a nice, kind of exactly what I want, right? And I still have this joint in the middle, which is actually bound to that curve, so I can actually pull this and move around. And because it's set up dynamically like that, it's actually going to still use those same controls, because the curve is what drives everything. Cool. So what exactly did I do? Where's my node editor? Cool. All right, kill this, kill this, kill this. Great. So let's take a look at the joint curve itself. Let's just graph that. Looks complicated at first. It's not. Okay. So here's a curve, here's a multiply divide, here's another multiply divide, and here's a curve info, and here's the curve shape. Alright. You could probably do this like a ribbon or something like that if you want something a little bit better, but whatever. Alright. Let's just clean this up a little bit. Boop, boop. I'm going to put all my joints over here. This one's going to go right there. This one's going to go right there. This one's going to go with this one. And that's going to curve. That's going to joint. There we go. I only wanted to look at one of my curves, but that's fine. Okay, so one of the things I do is I have a master multiply divide on there, and basically what that guy is doing is just multiplying whatever values come from the joints and sending them, as a multiplier into what the joint is. So the joint themselves have a value on them. I have a channel I'm going to add called power multiplier. So basically what that's saying is it's going to feed into the multiply divide. And I'm just doing a multiplier on that from this master here, which is connected to nothing at the moment. But that's going to just take this multiply divide and divide, multiply the two of them together, and then you'll end up with, a way to override that system. So what I'll show you is I'll grab this, pull it out, and I go to that multiply divide there. It has no inputs at the moment, so if I just take this value and crank it up, you'll see how it's squashing it more. Squashing it less. So let's go more, like a lot, like really overdrive it. Now watch what happens when it comes down. It's going to really go crazy, right? That's just, simple math. No big deal there, right? So the next thing is that's going to go into the actual multiply divide that's set to, where is it? Okay, so that multiply divide there is going to be from the joint itself and that master, just to create a new value, right? So that value is going to go to my power multiply divide. So this is basically a multiply divide, and you can just do a regular multiply divide, for those of you that aren't familiar, and then just set that to power, right? Okay, so basically just get a power function instead of multiply or divide. And so it's going to take that value, which I'm going to get to from a second, and put it into the scale y and z of my joint. So it's only going to affect those values. So where is it getting its original input from? So there's a thing here called multiply divide, and that's coming from my curve info. So you've probably done this before where you've taken a curve, create a curve info node, and you pipe that in, and then you get a multiply divide out of that. And basically what you're doing is when my joint is at, when my system is all at default 0, 0, 0, 0, my curve shape has a certain distance. So that's what the curve info is going to give me. One of the things it's going to give me is the arc length, which is the full length of that joint, of that curve. So when I take that curve and I multiply it by its original length, it's going to give me what? 1. Yes, of course. So at this point, nothing's happened. If I was to pull this a little bit, actually let's do this. Let's copy that tab so you can see this happen. So if I was to pull this, so what's going to happen is my curve info is going to give back that arc length. This is now longer. So the multiply divide, if I'm dividing by my original length, is going to give me a value of being stretched. And then that stretched times my my value here that I've given it, which is just an arbitrary value, is going to then go into the YZ here. So if I go and look at the joint itself, and I change this to say like 0.5, you see I get some value here, right? So if I take the 1.44, which is my new value coming out of the multiply divide based on the length of the curve, and I use the power function in the -5 there, what I'm going to end up with is some squishing. Pretty straightforward, right? Right. Cool. Let's put that back to 0. And basically what I do is I just do that, I have that function over and over and over again, all the way down the joint chain. So top one is 0, second one's 0, third one's 1, fourth one's 1, first one's 0. So actually let's take this one and make it like 0.5, let's say. This one here and also make that one 0.5, let's say, and let's see what you get. Something a little bit more natural, right? Cool. Now the other thing is the stretch. So stretching is basically just the same thing. I'm gonna take that curve info node, multiply divide it, and actually what you'll see is this curve, this multiply divide is very important to go to basically everything. So to figure out our length, what we do is take that multiply divide again. So remember that it's just the distance minus divided by itself, its original distance. So that's going to give me a value. So right now, since I've stretched it, that value coming out is 1.5, and then I multiply that against its original length, or translate x of the joint itself. So let's put this back. And so right now, you see how I get a value of 1.5? That's its original length of that joint. It just so happens to be exactly that. I didn't plan that. That's just sort of how it happens. So my original multiply divide here is going to spit out the difference between original curve length to multiply it by new curve length divided by original curve length. Gives you a value. That value is multiplied times the original translate x of the joint, and the output is the translate x, the new translate x of that joint back into that joint itself. So as I drag this out, that joint's going to get longer, right? Kind of makes sense. I can do a more in-depth, slower version of this, but I just wanted to do an overview. And so now I have a basic squash and stretch sort of ball here that I can make it hop around, grab this joint. You know, I probably wouldn't keep these as joints. I'd probably make them into controls, so I'd use my other little tools to make some quick controls on there. That looks good. Let's show curves only for a second and take these guys and twist them. Did I do a full twist? Whoops. No, that's good. Let's take this tool and do a quick Roy G Biv on them. Where's Roy G Biv? There's her, boop. And then make them thicker. Cool. Bring back our sphere here. Let's take that original curve and just hide it. And now I have a nice little control here. And yeah, if you go too far, so now I've basically inverted that. You can kind of see, there we go. You can see that there's a flipping happening. If I show my joints, let's see if I go too far, I'm gonna flip that joint over, right? That's kind of just the nature of IK. And let's turn off, and turn off our joints again. Whoops, turn off joints, there we go. Give me curves back, come on. There we go. And again, gotta be careful of those values crossing each other, right? This is why I like to use something like a spline or something like that, or sorry, a surface instead. Let's take a look at why it's flipping while I'm here, because it shouldn't be flipping. Probably because my values are not great. So to zero those out. Where's my zero channels? There it is. I want to see that flip. Oh, come on, flip on me. Well, that's not good. There we go, there's the flip there. So that's coming from my spline IK. So if we play with this a little bit, we can get a better thing. So right now the up vector is Y. So what's happening is we're just crossing Y's there. So let's see what happens if we change that to Z. Z. Cool. Bring our geo back. Do the exact same motion. And since, unless I get really in there, it's not going to change that. But again, now I'm going to have a crossover on my Z values eventually. See that? Okay, so I think that's enough pontificating on this. Hopefully that's helpful, and I'll do, if anybody wants, I'll do a more in-depth